graphing, we solve algebra. So I'm just going to pick randomly one or two of these and make sure that everyone knows. Okay, let's do the easy one. What's the vertical asymptote?
2.
And we say x equals 3, right? Because that's the non-permissible. Because what would happen is, if I substituted, if I'm going through my table of values and I put a 3 in my x column, I get 0 on the bottom, undefined. So your undefined values tell you where your asymptotes are, right? Where the graph does not have a value. What about this one?
X plus 2, x minus.
Yeah, x plus or minus 2. Those are your vertical asymptotes. And then basically, and it says the domain without graphing, this is what you use to create your domain, right? You can, the easy way is probably x can be everything except, right, where your non-permissibles are. Here you'd have to factor. What about this one? X to the power 4 plus 1. No vertical asymptote, right? Because when I try to do this, if I set x to the power 4 plus 1 equals 0, if you have an even power and an addition sign, you're going to get this thing again. Not possible. It's possible to have an odd exponent though, right? This makes sense. This would have a vertical asymptote if you had x cubed plus 1 on the bottom. Because I could solve it, I can solve if it's an odd power, right? This has a solution, right? -1. But if it's an even power, any even power, there will never be a value that's non-permissible. Like x to the power of 6, 8, and any positive number. There'll never be an undefined value there. All right, and then E, you would just have to factor, correct? So everyone's comfortable with this? There are easier ways to factor, right? That's why you spend so... Sorry? Yeah, I would pull the factor of 3 out. It just makes things easier, right? 3 is a factor, but it doesn't affect any of the horizontal or vertical asymptotes, or the vertical asymptotes, I mean, so then x can't equal plus or minus 4, right? Okay, so that's pretty straightforward. Horizontals are a little stranger because you have to go by, you can either graph the whole thing and pick out your horizontal asymptotes where you think they are, but now we have kind of a system. So what's the horizontal asymptote of this one?
Y 0.
And why is it y equals 0?
The coefficient for the power of the...
Yeah, nothing to do with coefficients this time, just higher power on the bottom, right? Higher power in denominator. These are easy to pick out if you know that rule. How about this one?
2.
2, right? Same power. So I just cancel those out. 2 over 1 is 2. This one? 2/3, right? Highest powers cancel out. I'm left with 2/3. This one? Yep. Highest power, right? Highest power. Is everyone comfortable with this? These, just picking out the characteristics. And then this one? Almost. Right? Kind of tricky, right? If you were kind of sleepy, it's a Friday afternoon. If you didn't rewrite things in proper form, you might have missed that, right? These 2 over -2, so I get -1. This one? Oh, this one. Okay, does this factor at all? Let's see. -1?
Yeah.
3x squared minus 3 plus 5. No, I think it's the other way around, right? Minus plus. Plus 3 minus 5. Okay, so then my vertical asymptotes, set each bracket to 0 and solve, so I'll get what? X equals 5/3, x equals -1, and then the domain would be XER except x can't equal -1, x can't equal 5/3. Right? There is a set notation way to do this if you prefer that as well. It's a little more complicated, but you can do stuff like, you'd have to do, is anyone interested in that, or you just want me to forget it? Does anyone want set notation? No. It's really yucky, right? You have to go negative infinity to -1, all rounded brackets, or from 1 to 5/3, and then 5/3 to positive infinity. It's really messy. Okay, what about this one? Same types of things, right? We good here? Yeah? Okay, and then the second page is matching. I know the graphs aren't the greatest, but, and they're from a graphing calculator, not even Desmos, right? So they're a little weird. But I see one vertical asymptote, one horizontal here, same here, same here, same here. What do we have down here, though? I see 2 verticals and 1 horizontal, right? So it is possible to get more than one. And we just saw that over here, right? Here I had 2 vertical asymptotes, here I had 2 verticals, here I have 2 verticals, so it's possible to have more than one. Generally speaking, even though these pictures aren't the greatest, but this is kind of how your graphs, most rational functions seem to be this set of wings, right? The wings, and the wings either shifted over one way. Sometimes you get a vertical asymptote with the wings on the same plane, right? So they could look like this, or they could be flipped over, right? You might get a pair of wings like this. But notice you'll never ever get a piece of the graph above and below each other, because it wouldn't be a function. You'll get them side by side sometimes. More often than not, they're the diagonal, but you can get them side by side. And then this one's a little strange. This one has the most pieces to it, I'll say. So you're looking for an equation that has 2 vertical asymptotes, but many times, if you have 2 vertical asymptotes, you're going to get a pair of wings kind of on the same plane, and you'll get what almost looks like a parabola. It's a really kind of flattened out parabola in the middle there. Whoops, sorry. Now, I've got a really messy graph here, but is this a function? Yeah, it passes the vertical line test, right? Even though things get really, really close to your asymptotes, it's still a rational function. The more parts to a rational function, the more complicated the equation was, right? Which one of these is the most complicated looking equation, would you say? Yeah, that's the most complicated looking picture. Which is the most complicated equation? 1, 2, 3, 4, or 5? No? Which is the most complicated equation? This one, this one, this one, this one, or this one? Which could go either way. I heard someone say 3. Who said that? Wow. Someone over here said 3. This has, how many vertical asymptotes would this guy have? 2 of them, right? If I factored, it would be x can't equal plus or minus 3. So you'd have vertical asymptotes at x equals 3, x equals minus 3. Well, there's only one graph with 2 vertical asymptotes, right? This guy. So that's another way you can do it. Anyway, okay? We're going to move on to graphing on Monday. So finish this up. If you have any questions for me, let me know. I don't think I'm going to move on to graphing, but I'm going to hand off this assignment for you. And if you want to have, it's a nice, well, it's a bit of a cumulative review. So